question asks, if 199 is a prime number, that is, a number that's only divisible by 1 and itself, what is the next prime number? Well, unless you've memorized the prime tables all the way up to and through that point and know automatically what it is, here is a situation where it makes sense to use the answers given, 211, 213, 217, 219, or 221. Where do you think is the first place we'd want to start if we want to guess the next prime number greater than 199? Well, it would be the lowest answer greater than 199. In this case, it's 211. 211 is the best place to start and check if that is indeed a prime number. The way we're going to check is go through the divisibility of the numbers. Is it divisible by 2? No, it's not an even number. Is 211 divisible by 3? We can check the divisibility by 3 of 211 by adding up the digits in the number and seeing if they're divisible by 3. In this case, 2 plus 1 plus 1 equals 4, which is not divisible by 3. The number is not divisible by 4 because the last two digits, 11, would have to be divisible by 4, and that is not true. It's not divisible by 5 because 211 would have to end in a 0 or a 5, and that's not true. The number is not divisible by 6 because it would have to be divisible by the combination of 2 and 3, and it's not even. So it's not divisible by 2, therefore not 6. Is it divisible by 7? Well, 7 times 30 equals 210, and 211 is just one more, not a multiple of 7 more than 210, so 211 is not divisible by 7. Likewise, it's not divisible by 8, which is also even. And if it were divisible by 9, the digits would add up to a number that would be divisible by 9. And of course, as we just discovered, the digits add up to 4 and are not divisible by 9. It's not divisible by 10 because it would have to end in 0. Is the number divisible by 11? Well, no, that's not true either, because 11 times 20 is 220, and that is 9 greater than 211. It's not a multiple of 11 different. So 211 is not divisible by 11. Likewise, it's not divisible by 12. Again, it's not even. Look at 13 times 20, we know very quickly, is going to be 260, minus 3 times 13 equals 221, and that is different from 211 by 10. And 10 is not a multiple of 13 different, therefore 211 is not divisible by 13. So, do we need to go any further at this point? Here is one of the keys to solving this problem and knowing that you've exhausted all possible solutions. The answer is no. We do not need to go any further at this point. And you can see that if you note that 15 squared, which we all should know from our practice drills, equals 225, which is a figure greater than 211. So, you might wonder, is 211 is divisible by 20-something, or 30-something, or 40-something? Well, if it were, you'd have to have a much smaller number paired with that. In other words, if it were 20, to get something like 211 would have to be multiplied by 10. And if it were 40, to be a factors of 211, it would have to be something like even a lower number, 5. Both of those actually equal 200, but you get the idea. They're pretty close to 211. So once I've exhausted all the numbers up to 15 squared, which we know is greater than 211, we no longer need to go any higher because we've already looked at the smaller number pair that would go with any higher number by looking at divisibility from 2 all the way up through 13. And 14, of course, which isn't even, and 211 is not divisible by 14. So that means we've exhausted all options. 211 is indeed a prime number. And that is our answer on the very first example from the given answers that we checked, which is nice and convenient. But realize, one of the keys to this problem is noting that you don't need to check divisibility beyond 15 if the square of that number 15 is greater than the number you're checking, whether it's prime or not. I hope that helped and is informative. Thank you, Einstein.